Alright, we're going to do a first video on scientific notation, and it's going to be a very, very brief intro. First, you can kind of see purpose. You guys can write this down. The reason or the whole purpose for scientific notation, they're used to represent very, very big numbers or likewise very, very small numbers. There's a lot of numbers written, so we can kind of use scientific notation to kind of condense it and make it look a little bit easier, and it's easier to work with. Now, let's look at these first two examples. You can see we have given scientific notation. We're going to write the actual number. So if we have this 5.76 times 10 to the fourth, well, if you take anything and you multiply it by a base of 10, if this exponent is positive, then to write the actual number, I'm going to move this decimal place to the right. So if I move this decimal place to the right, it's right here. Now, since this exponent is 4, that means I move this decimal place to the right 4 places. So 1, 2, and then 3 and 4. So I'm going to add 2 zeros in right here. So this actual number is 576, and then I add 2 zeros in. So this is 57,600. So that's a really big number. You can easily state it as 5.76 times 10 to the fourth. That means the same thing. Now, the other way, if for this next one, if it's raised to a negative exponent, then that means that's going to represent a very, very small number. Now, this one, what this means is where this decimal place is, okay, it's right here. If it's negative 7, I'm going to move this to the left 7 places. So see, I move it here once, and then I have to move it over 6 other places. So if I actually use the red ink right here, I move this once, but then I have to go 2, 3, 4, 5, 6, 7. So I'm adding zeros in here. So this is going to be, there's going to be 6 zeros. 0.0000000, right? That's 6 zeros, and then 9235. You can see how it's very annoying to write this out. The 0.0000000. 9235, it's even more annoying to say. This is a much, I guess you could say, cleaner and more efficient way of representing that very, very small number. So to kind of sum it up, if you have a number that's in scientific notation, if you want to find the actual number, well, if it's a negative exponent, then you move the decimal to the left. Okay, kind of makes sense. When you go to the left, it gets smaller. If you have a positive exponent, then you move the exponent to the right. And that's what we're going to do. There's 4 problems underneath, so let's apply that. Now, these are all in scientific notation. Let's write the actual number that it represents. So the first one, we have 3.65 to the negative 4. Since it's negative, that means I'm moving the decimal 4 places to the left. So it's 1, 2, 3, 4. So I'm going to have 3 zeros in, 0.000365. Okay, easy way to remember, if it's a negative exponent, the actual number is very small, and 0.000365 is very small. Okay, number 2, it's raised to the positive 7, so that means I'm going to move the decimal place 7 places to the right. So let's see, it's going to be 1, 2, 3, 4, and then 5, 6, 7. So I'm going to add 3 zeros in at the end. So this number becomes 3, 5, 6, 4, 7, 8. 1, 2, 3. And then I add 3 zeros in. 1, 2, 3. So this is a very, very big number. So 356,478,000 is represented by the original number in scientific notation. Okay, number 3, this is raised to a positive 5th, so I'm moving the decimal 5 places to the right. So it's 1, 2, 3, 4, 5. So I'm right in between the 6 and the 2. So this is the same as saying 76.2. And number 4, this is raised to the negative 8. So I'm going to move this 8 places to the left. Now you might say, well, where's the decimal? Well, this is a whole number, so the decimal is right here. So I'm moving this 8 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8. So it's right there before that 8. So this is the same thing as saying 0.85. Okay? So you can kind of see right here the basics. If you have a positive exponent in scientific notation, we move it to the right. If you have a negative exponent in scientific notation, we move it to the left.